This is Matagorda Bay, Texas. The United States Army Corps of Engineers studied a proposal to relocate the navigation channel here. It tracks right back here along the mainland. It dips down here and runs on through and continues on down the coast. And they were going to relocate it to something a bit higher up here. The cost of doing so are largely the cost of dredging the new channel and disposing of the dredged material. The dredged material in this case was going to be disposed of along the coast here. Containment structures were going to be built, and they would be using geotubes. So let's take a look at a geotube. This is a geotube. They're like gigantic sausage casings that are placed offshore, then they're filled with sand. And then the area back here behind it is dewatered, and the dredged material is placed back here in a containment area. Let's take a look at the cost of doing this now. This is a simple model. Here we identify the work unit to be accomplished. The quantity of work and its units of measurement are given here. The unit price of the work is given here. And this is all very straightforward except for the fact that these quantities are uncertain. There are many factors that go into determining an estimate of dredging costs, for example. In fact, there's a separate model just for doing that. As a result, virtually all of these inputs are uncertain. So let's take a look at this distribution. This is a very peculiar looking distribution that was generated from that model that I mentioned earlier. This distribution was originally developed in a cumulative fashion here. You can see the data up here was transferred over from another model. The quantity of material to be removed in a particular area of Matagorda Bay is also uncertain, and here you see these values are estimated as triangular distributions. The value obtained here is a value obtained. The most likely value here was obtained from a model used by the U.S. Army Corps of Engineers, and they provided error bounds for these values as well. This model makes a very simple point for us. A quantitative risk assessment model can be anything that you can calculate in a spreadsheet, just as long as some of the cell entries are uncertain. So keep in mind that a quantitative risk assessment need not be super sophisticated. It only needs to be honestly dealing with the uncertainty that's present in the problem. In this course, we're going to stick to spreadsheet models because the spreadsheet is a very flexible and valuable format for model building. It also has the advantage of not requiring any special programming skills, so we can all participate and learn in the spreadsheet environment. Fortunately, a number of powerful tools have been developed to enable us to do sophisticated risk modeling with spreadsheets. So let's have a look. Right now you can see down here this red number. This is the estimate of the project cost. But what if instead of $2.78, let's turn on our Monte Carlo process here. Suppose it's $2.91 or $3.05 or $3.16 or any of these other values. Well, what we're going to do is we're going to calculate this cost 10,000 times. And you can get an idea how this quantitative risk assessment works. It uses the tools, the skills, the ideas that we've developed in earlier classes, and it structures them in a way that's useful to support decision making. So right here we have a model that says we've got somewhere between $14 million and $26 million in cost. And most likely we're going to have a cost somewhere in here in the 18 millions or so.